okay? Just so we don't run out of time. Okay, remember in general we have a plus b log x in general. In this case, or natural log of x, in this case this is b and that is a. They flipped it on you. I did it on purpose because I don't know if they might do that to you. This is y and this is x. Y is always on the left, x is always on the right. Always, okay? On an equation. What does that stand for? T stands for time in years, I'm guessing. Yeah. Yeah, we'll just call it, so P is percentage. And this is time in years. And I know what some of you, your brain is now saying, oh, I get it, logarithmic, time is always the y. I got it. It's like, no, not always, but logarithmic is one of the ones where they do that, okay, specifically. Let's make a graph. So what do we know already? B is negative. Okay, so in general, that means that this is going to happen. Okay? Because B is negative, it's going to happen. We don't care about this part because time can go down to 0, but it can't go into the negatives. So we're interested in this part. Okay? So when you make a graph for a logarithmic, what is the most important point that you must find for a logarithmic? I may or may not be pointing at it. X-intercept. You have to find it. That's like your only real anchor. Okay? So let's find the x-intercept on the side here. Let's find it together. I'm going to type in that equation. Whether or not you follow me, that's on you. 43.2809. It's natural log, so make sure you get that. Plus 199.316. No matter how scary they look, you just do what needs to be done, okay? Remember my window was way too big, like where X is 100,000 max, so I'm gonna go zoom standard. And I don't see this. X is what, percentage? So what's the highest percentage we're gonna get to along the X? Probably 100, right? So I'm gonna go 120, hit graph, there it is. And in terms of the Y, is there a single max you're ever gonna get to on the high? Probably not. So I'm just gonna go 100 for now. And I would say for now that is good enough because you know it's never gonna touch the y-axis. So let's find this one here, second trace 5, enter, enter, enter. No surprise, it's 100, 0. Think about it. At time 0, you have 100% of the radiation, right? 100%. So let's do our graph here. This is what I really wanted to get at so that you have a graph on this one. And I'll make this 10, so I make this 20, 40, 60, 80, 100. That's what I'm going to do for, you know what, why not go by tens? This is 50, so this is 50%. And then I'm at 60, 70, 80, 90, 100. Bless you. This is 100%. This is radiation level as a percentage. And this is time in years. I know that 100 zeros right here. I know that my graph based on the calculator and based on what I already knew about the function, that it's going to do this. So what do you do to help you out? Find a point somewhere. Let's go find halfway right here, 50. So I'm going to go second trace 1, x is equal to 50, and I know it's 30 for my y. So I'm going to go 50, 30. And let's find another one that's a little bit closer to the, how about we go with 20 or 10, one of them. I'm going to go second trace value 20 maybe. I'm at 69.65. 66, sorry. And that's good enough, okay? So 50, 30, 20, 69, or 70, right? So what I'm going to do is I'm going to go 10, 20, 30, 40, 50, 60, 70. Okay, 20, 40, 60. And I'm just going to label here time in years. And that is going to help me here. So 50, 30. 50, I'm at 30. 20%, I'm at 70. Way over here. So I'm going to go like this. I know I'm going to kind of butcher it a little bit. But that's what would happen in this case. Okay? That would be the expected graph. T is equal to negative 43.2809 LNP plus 199.316 for the graph. Okay? Let's do the domain and range, might as well. E, domain and range. What would be my domain for this situation? Like, that it gets closer and closer to 0, but it never actually reaches 0, correct? So my domain is going to be 0 not inclusive to 100 inclusive, because we can get to 100% on the x. My range, what's the lowest I ever get to in terms of time? Right? If you go across here, right, you trace it out and you travel along the y-axis, it will be 0. And since this doesn't really ever seem to stop, in terms of your y, you never cap. So this would be 0, infinity. Okay. Okay,